Welcome to our third and final Q&A session for BM Cycle 4. Today's session will cover the challenge statements under the thematic pillars of building inspection, maintenance and facility management, and automation and robotics for construction. I'm your host for today's session, and today we are joined by our challenge statement owners as well as representatives of the BM committee. To kick us off, I would like to invite Arne Leong, Executive Manager from the Built Environment Technology Alliance of BCA, to say a few words. Arne, over to you.
Yeah, thank you, Zipeng, and a very good afternoon to all. I'm Arnold from the Built Environment Technology Alliance, or BETA in short, an outfit at BCA. So once again, a very warm welcome to the third Q&A session of the Built Environment Accelerate to Market program, or BM in short, a platform to bring innovators and firms together to fast-track the innovation process to solve challenges in our sector. So after an exceptionally challenging few years with the COVID pandemic, we are finally seeing an evident recovery, as well as a strengthening of the sector and reopening globally. And the built environment sector is therefore seeking to both regain lost ground, as well as to break new grounds. And this cannot be achieved without the technologies and innovative solutions that have now become imperative to the firms and their businesses. So as the sector emerges stronger, we are optimistic of the new opportunities for technology and innovation. So this year, we are in our fourth cycle since the inaugural one in 2019, and we are glad to continue this partnership with Padang & Co., our appointed accelerator, as well as Enterprise, Singapore, and JTC. I'm glad that you have taken some time this afternoon to join us today and be a part of the BM Cycle 4, which has continued to garner the interest from the industry with 13 challenge statements in areas such as digital asset delivery and project management, building inspection, maintenance and facility management, automation and robotics for construction, as well as advanced design and fabrication. So to our challenge statement owners, it is encouraging to see new faces as well as some familiar ones whom we are grateful for their continuing support. And we warmly welcome you on this journey with us to build up our built environment innovation ecosystem, to co-innovate and create new partnerships. To our prospective innovators, this is a window of opportunity to establish networks with our firms as well as potential investors to develop new expertise or match your expertise with the industry firms. And in doing so, we hope that sustaining investment partnerships can be forged between our innovators and firms and lead to both building up their innovation capabilities and new competitive advantages to bring about greater growth and revenue. The theme of today's Q&A session will be in the area of inspection, automation, and robotics. And we'll see each of the four firms, namely EM Services, Penta Ocean Construction, Trundling Construction, and Wohub make a short presentation and providing more insights to their challenge statements to allow prospective innovators like yourself to appreciate the challenges at hand and understand the requirements, and hopefully inspire and generate new possibilities towards the desired solutions and outcomes. So please feel free and do not hesitate to step forward and clarify. And last but not least, we hope you will find this session fruitful, enriching, and inspiring you to develop new and meaningful partnerships. So I wish you all a good start to Cycle 4 as you embark on this exciting BM journey. And over and back to Zipeng to continue the session. Thank you.
Thank you, Arne, for the encouraging message. I must highlight that Arne is an important champion for BM, and you will definitely hear more from him and receive his generous support if you were selected for the program. Introducing myself, I am Zipeng, Head of Programs from Padang & Co. Padang & Co has been appointed to be the acceleration partner for the fourth cycle of BM, and we have exciting plans in store for our previous cohort of innovators, as well as the innovators that will be selected for Cycle 4. This is the agenda. For today's Q&A session, I will first give a brief introduction to BM Cycle 4, answer some questions that you might have regarding the program, And then we will proceed to hand over the time to our challenge statement owners to share about the challenge statements that are listed on this slide. Representatives from the BM committee will also be staying back at the end of today's session to address any further questions that you might have. The Built Environment Accelerate to Market Program, or BEAMP for short, is a great platform and opportunity for innovators like yourself to co-develop, test bid, and pilot solutions with our challenge statement owners. You will work in close consultation with the challenge statement owners to refine your solution based on their requirements, and thus get your solution ready for adoption and commercialization. Furthermore, successful eligible innovators will enjoy co-funding support from Enterprise Singapore for prototype development, test beds, and pilot development. Successful innovators will also enjoy pitch coaching and refinement, specially tailored for your company's business and solution to prepare you for industry showcase events that we will be organizing, such as the Built Environment Demo Day. BEAMP is also a great platform to access a widened network of partnership opportunities and expand your company's exposure to local and international networks. I would like to take this opportunity, do a quick shout out to our ecosystem partners that have kindly agreed to support BEAMP. We are currently in our 4th cycle of the program. We have worked with over 50 industry firms to identify 93 unique challenge statements. We have awarded a total of 35 projects over the past 3 cycles. You can learn more about our past projects by visiting the stories page on our website, beamp.sg. My colleague will be helping to drop the link in the chat. For cycle 4, we are excited to have these leading firms of the built environment sector to come on board as our challenge statement owners. Some of them are longtime supporters and also beneficiaries of the program. On the other hand, we also have new firms that contribute a diversity of challenge statements and thus new innovation opportunities. Today, we will be featuring the challenge statements under automation and robotics for construction and building inspection, maintenance, and facility management pillars. This is our final Q&A session, and the recording from today's session will be posted on our website, beamp.sg, within 2 to 3 working days. The recordings from our previous Q&A sessions have already been posted on our website and can be found under the resource section under each challenge statement page. These diagrams explain the process of making an application up until the award of projects. We are currently at the first step, which is our Q&A sessions. We encourage innovators to maximize these opportunities to ask questions to our challenge statement owners so that you have all the information needed to prepare your proposal. Proposals submitted by the 14th of October will be shared with our challenge statement owners for preliminary reviews. Selected submissions will enjoy priority to schedule consultations with our challenge statement owners. You could also benefit from the feedback provided by the representative of the BM committee, which comprise of staff from BCA, JTC, Enterprise Singapore, and Padang & Co. Resubmissions of your proposal is allowed until 7th of November this year. 7 November would also be the application deadline for innovators that did not make an early submission. Depending on your relevance and overall strength of your proposal, selected innovators will be prioritized for the consultation sessions, where sessions could happen at any time between the early submission deadline and selection of an innovator by the challenge statement owners. Please note that there might be multiple sessions with the objective of ensuring clarity and alignment between the innovators and challenge statement owner, especially on the outcomes of the resulting project. The evaluation and shortlisting process will occur in the following manner. Your latest application for BM Cycle 4 will be reviewed by the BM committee and our challenge statement owners. The BM committee will be checking your application details to ensure that you are eligible for the program and funding and conduct their own assessment of the proposal. The latest version of your proposal will also be channeled to our challenge statement owners. The final rounds of consultation sessions will be arranged, and once the challenge statement owner is confident of their selection, they would issue a letter of intent to their preferred innovator and their feedback on the innovator to the BM committee. Innovators will then be shortlisted by the committee with consideration of the feedback from the challenge statement owners and the outcomes described in the letter of intent. Shortlisted innovators will be invited to present their proposal to the BM committee and provide further clarification as needed. The decision to award ASD or MD projects will happen in January 2023 onwards. Awarded innovators will need to complete the grant application process in order to receive the requested funding support. Projects may commence once you receive notice from BM committee regarding the award. There are two development tracks for the BM program, which is our Accelerate Solution Development track and Market Development track. Let me explain both tracks a little more so that you understand which track to apply for. If your company has discovered the challenge statement and is in the early stages of developing a solution that could potentially address any of our challenge statements, you should apply for the Accelerate Solution Development track, or ASD for short. The scope of development for the ASD track should be planned to be completed within 3 to 6 months. Example of activities that could be carried out during ASD include user studies, tests to ensure usability of the solution, develop prototypes or run simulations to demonstrate technical feasibility and accuracy, align the solution blueprint and pilot implementation plan with stakeholders, or conduct cost-benefit analysis to ensure viability of the solution. BM will help subsidize your development costs. Funding support for the ASD track is capped at 30,000 Singapore dollars or 70% of the qualifying costs. If your company has already developed a prototype or early product and you have identified there are further developments needed to ready your solution for adoption and commercialization, you should then apply for the Market Development track, MD for short. The scope of development for MD track should be planned to be completed within 12 months and should result in a complete solution that can be commercialized. For the MD track, you should seek to further develop your solution to sufficiently address the requirements from a group of demand drivers that can serve as your early adopters. Activities could include deployment and testing of your solution in sites with real operating conditions, integration with existing systems, and practical developments to make your solution enterprise ready. Funding support for the MD track is capped at 250,000 Singapore dollars or 70% of the qualifying costs. It is important to note that projects that successfully complete the ASD track are eligible to apply for the MD track to continue the solution development initiated during ASD. I hope that I managed to pique your interest to apply for BM Cycle 4. After you learn more about the challenge statements, these are the steps to apply for the program. Step 1, visit bm.sg and click the Apply Now button found at the top right corner. Download the proposal template and fill it out. Complete the online application form, upload your proposal and the requested documents such as your Accra business profile, pitch deck, and CVs of the core development team. I believe my sharing has helped you gain clarity regarding the BM process, but there might be some details that I have missed. I'll pause here for a few minutes to address any questions that you might have. So you can click on the Q&A section and submit your questions. Okay, so I believe that I see that there's no questions, and I just want to proceed to the challenge statement presentations. Oh, there's one question that just came in. Can projects that are not listed in the challenge statements be considered? The short answer is no. Projects that are not based on the challenge statements won't be considered for Cycle 4. but we would encourage you to approach the BN committee because ultimately we are looking to support the built environment ecosystem of innovators. So do let us know what you have in mind for the built environment sector, and perhaps maybe for future cycles, your project could be included. Okay, yep. So proceeding to our challenge statements presentations. These are the 4 challenge statements that will be featured today. And to start off the presentations, we have Dr. Lai Wing Chuan from EM Services, who will be presenting on the routine inspection of corridors of HDB blocks. Dr. Lai, over to you.
Thank you, for the time, and good afternoon to everybody. Just to give a brief background of who we are, EM Services basically is a managing agent of town councils. There are currently 17 town councils in Singapore, and we manage 10 out of the 17 town councils. So some other numbers that you may want to know is that out there are about 10,000 blocks of HDB flats, and total units of household is about 1 million. So we kind of manage 2/3 of them. So our day-to-day in terms of managing estate, so we will share today one of the challenge statement of what we do, and hopefully the audience out there could provide us some solution. One of the things that we do is a corridor inspection. So some statistics again in terms of the number of blocks out there, and each town council, there are about 600 blocks. So that is it could be more than 600, it could be less than 600. It's about average about 600 blocks. All right. So for one of the tasks that our property office do is to do corridor inspection, and there is a common areas in front of the flats, and to look for hazards and any defects or obstructions. And this is done once a month. It could be done more if there are more problems with that area. And the buildings could be ranging from 2-story to 50-story. For example, Pinnacle is 50-story. So what do we look for? This graphic basically show you some of the things that are allowed and some things that are allowed in the corridor. So obstruction that would basically hamper the movement of people, especially in terms of during emergency. It's critical that there is enough clearance space for the rescue people or the SDF people to move. So typically we need a space of 1.2 meters. So that is a requirement in terms of clearance in front of each unit. So other things that we inspect, typically, for example, like on the wall, any cracks, any boulding plasters, spalling concrete. So we also be looking at that, and all these are done visually. All right. On the corridor parapet, any corroded missing railing, anything that is hazardous placed on that maybe fall off, become kiloliters. The lighting as well, any flickering and lodged or dislodged light fittings. The lightings are mainly done at night, not during the day, and any fire hazards that is left along the corridor. All right. For example, abandoned damp cardboard boxes, or even sometimes we see gas cylinders, which are definitely hazards. Okay. Then the scupper drain, basically, the drain for rainwater just below the parapet. It shouldn't be blocked, or there shouldn't be any water ponding, so that mosquito doesn't kind of breed over there. And as mentioned, we need about 1-2 meter clear passageway for movement of people and trolleys and so forth. Cleanliness as well. Any so-called spider web, for example, even birds' nets, or even hornet's nets. Some of these things that can appear on the corridor. So these are typical things that our property officers will go around and inspect in each and every floor. Okay, so this is, as I said, it's very manual. So we're looking for some automated solutions with some video probably, and with video analytics as well. And with some automation in the sense that, probably like robotics, where the robot can travel from floor to floor, which means that the robot needs to be able to take lifts. In most blocks, they will have at least one lift. Most lifts have 2 lifts or more. So the robot need to be able to interface a lift, take lifts from floor to floor, and able to do the necessary inspections. So given the so-called the number of blocks that we cover, I think we need to probably, in terms of able to do inspection, I think we need some product improvement, which I'll touch on later. So these are some of the things that challenges that we see. Navigation. So as I said, the robot cannot be too big. You're given 1.2 meters in terms of corridor space, which the robot need to move or even turn. Within the lift itself, the door opening is about 900 mm. So the robot need to be able to go inside the lift and reverse out or turn inside the lift as well. So that is the space limitation that is so-called allowed. And the robot has to operate autonomously. And sometimes there need to be some human intervention, especially in when the robots hit some situation where there may be some conflict that it is unable to continue autonomously, then you may need remote piloting. All right, somebody from a command center able to see all the video stream coming back, and able to manually pilot the robot to get the robot out of the difficult situation. Okay. Some other requirements in terms of given down there, human avoidance, noise generation, because these are along the corridor, and we intend to do the inspection at night, so where there's little people movement. So especially in the middle of the night, that's what we are targeting. And if we deploy the robot in the middle of the night, it should not generate too much noise. Okay. Then it should be able to navigate from block to block. As mentioned just now, that during between hour, let's say 11 to 4 a.m., there's a time the robot can go and inspect the blocks. So we expect that during that time the robot should be able to inspect more than one block. So that's hence the requirement that they're able to navigate from block to block. Installation is more of if we deploy at night, it's more of rain. Heat if we deploy out the day. All right. So rain may fall, especially between blocks. There may not be any protection. So the robot need to have some IP protection. Okay. We mentioned about connectivity to the command center. Okay, whether 4G, 5G is so-called accepted, because we need to do remote piloting. All right, and battery lifespan of about 6 hours. That's between that's why between 11 and 4 or 5. So we need that kind of battery life. Yeah. So lift interfacing, again, we say that no human intervention. So the robot should be able to take the lift, and we have various lift brands out there. And this lift could be as old as 20 years and as new as less than a year. All right. So the robot should be able to interface with these different brands of lift. And to take some reference, there's this technical reference TR93, which you can refer to, that will give you some information on how to interface robot to lifts. This may not be the only way to interface, so you are free to propose other interfacing method, or even some attachment to lift control panels as well. All right, but bear in mind that this whatever that you add on or where you interface, you have to interface with different brands of lift. So human control, as mentioned, is that in case of conflict, in case of the robot unable to resolve any navigation issues out there, then the human command center should be able to take over and remotely to pilot the robot. Okay, I think that was my last slide. So I'm open to questions and answers. Thank you.
Thank you, Dr. Lai. Yeah, thanks for turning on your video. Yeah, so to our attendees, if you have any question, do submit inside the Q&A panel. So, Dr. Lai, a question
Yes.
from of my own. So, would you have any preference regarding the type or form of robotics? For example, I mean, there are those that you see at the shopping center, or there's like robotic dogs.
There's no preference, but basing on the terrain and what we know the robots out there, is that probably a wheel robot would be more suitable. Yeah, because I think the key thing is the so-called the battery life. Right, there are a lot of fanciful robot out there, but the battery life may not be sufficient because the robot also need to carry cameras, your computational so-called power, everything on the robot. And with this on the robot itself, then you need to have a certain battery life. Yeah. Hope that answers the question. Yeah.
Yep. Thank you. Yeah. Another question. So, just considering your operations at the HDB blocks, would there be any other things that the robotic solution can do to add value, perhaps like cleaning the floor?
Okay, so we're open. All right. So put it that way. I mean, once if this solution is workable, then it can deploy to any building. All right. For example, you talk about virtual patrolling in terms of security, it's the same thing. Okay. We don't need virtual patrolling HDB, but this robot could be deployed in such scenario. Okay. Or once the solution is workable, then we can do the last mile delivery. All right, for example, currently that most of the delivery system in the robotic that you see, for example, in Pongo, only deliver to the void deck, the ground floor. All right, with this solution, basically, then you could do door-to-door delivery.
Very interesting.
Yeah.
Yep.
Okay.
Okay. So I don't see any questions. For those watching the recording, if you have any questions for Dr. Lai and his team, you can send your questions to bm@padang.co. Yep. So, and we will channel it to them so that they can help address your queries so that you can prepare your proposal. So with that, thank you so much, Dr. Lai.
Thank you for the time. Thank you.
Yeah, with that, we'll proceed to the next challenge statement. This challenge statement has been contributed by Penta Ocean Construction. Nicholas, to invite you to turn on your video. So Nicholas will be presenting on automated grinding for concrete wall and ceiling services. Over to you, Nicholas.
Yes, thank you, Zipeng. So my name is Nicholas, and I'm a BEAMP specialist in Penta Ocean Construction. So Penta Ocean, we are a main contractor, and of recent years, we have been doing a lot of MRT stations, hospital projects. So for this BEAMP Cycle 4, we are inspired to actually see how we might automate grinding for concrete wall and ceiling surfaces to increase productivity. So on to the background. So concrete grinding is usually done to remove the defects on concrete surfaces. These defects are such as unevenness, bulges, and drips. And this is done so that the quality of the subsequent architectural finishes that are put on the surface are not affected. And for walls and ceilings, the grinding is performed manually by workers using handheld grinders. And the operation is usually very intensive, and it poses health and safety hazards to workers during long operations. And additionally, when working on surfaces that are of up to 6 meters or more, work at height equipment are needed. And working at height actually adds another layer of complexity because that requires more manpower to manage the safety risks and the other risks that are involved. And then after concrete surfaces have been grinded, they often still require additional treatment, such as skim coating and plastering, before the concrete surface is ready for architectural finishes. So as a guide for the current practice, we look at the concrete surface profiles So in short is CSP. It gives the concrete surface treatments 10 different classifications, and they are named from CSP1 to CSP10, with CSP1 being the finest and smoothest surface, and CSP10, of course, having the roughest and most uneven surface. Now, where concrete grinding is concerned, a range of CSP1 to 2 is the expected level of surface treatment. Now, the concrete surface, where at CSP1 to 2, will be ready to receive finishes of not more than 10 millimeters, such as paint finishes. So you can see these two images here, showing what CSP1 and 2 looks like. Okay, so for opportunities, what PentaOcean is interested in are robotic solutions. They are able to partially automate concrete grinding works as a start, and then it can later on be developed into a fully automated solution. So for example, in the early development stages, a worker can deploy the solution to do concrete grinding for a chosen section of wall or ceiling, and then afterwards go on to do other activities. Then after the work for the section is completed, it can return to turn on the machine for the next section. So what this does essentially is that it frees up the workers to perform other activities while also eliminating the safety risks associated with grinding, because there's less need for physical monitoring of the work done. Then for requirements, so this list of requirements needs to be fulfilled for the solution to be considered successful. So they are basic criteria that would make the solution feasible to use in construction work. So firstly, it should accurately grind all assigned surfaces to a consistent surface quality. Secondly, it needs to accurately identify the quality and defects on concrete surface and also adapt to grinding. Thirdly, it needs to minimally perform concrete surface grinding at 7.5 meters squared per hour, and it needs to grind surfaces of up to 3 meters in working height. So it should also allow for interchangeable parts for different grinding discs and different grinding activities, and the resulting quality of work should follow the standards of CSP 1 and 2, which was mentioned earlier, and also comply with the BCA Conquest 2019 standards. Now, it should also perform in full consideration for safety on site, health, and environment, and it needs to support data collection on work done for progress checking and inspection purposes. Then it should be able to operate on site through on-site power generators, especially in construction sites. And last but not least, it needs to be able to fit in vertical transportation and work at height equipment. We also would like to have some more add-on performances for the solution, and this would be desirable. What would be desirable is that if the solution is able to be designed to access heights of up to 6 meters or more when integrating with common work at height equipment. And secondly, if we can improve the quality of works to reduce or eliminate surface treatment works such as skin coating and plastering, it will help us reduce the need for preparation for paint finishes and other architectural finishes. Then if the solution should be able to traverse and park on uneven slope or stepped areas. And lastly, this is desirable that the solution should consider how grinding can be done for joint areas, such as vertical or horizontal elements, like slab soffits or interfaces between wall and floor joints, and also joint areas between adjoining elements, such as wall-to-wall and slab-to-slab interfaces. So for outcomes, ideally, we want a solution that can provide autonomous concrete grinding, which essentially means that it needs to complete the concrete grinding work without human intervention, except for deployment, redeployment, and termination, and also do so accurately and quickly over 7.5 meters square an hour. So ultimately, the solution will actually reduce or eliminate the need for manpower, allow for remote execution, reduce the total cost and time needed to prepare a concrete surface for receiving architectural finishes. Okay, so I believe that will be the end of my presentation. Yeah, so now if I have any questions or to be taken.
Yeah. Nicholas, would you be able to share more information regarding the projects that you wish to deploy this solution at?
So for this challenge statement, right, is we are intending to apply it to one of our ongoing projects for MRT project. For a transportation project. So we want to use this solution to actually grind a lot of our walls to make sure that we can apply a paint finish directly onto concrete surfaces. So to do so without any defects, we need to make sure that the concrete surfaces are smooth and doesn't cause any kind of future problems when it comes to defects. Yeah.
Thank you, Nicholas. Another question. So, in your slides, you mentioned full consideration of the safety, health, and environment. So, what are the things that is important to consider? For example, dust accumulation.
Yes, dust accumulation, of course, is one of them. Because when it comes to dust accumulation, it could lead to basically not just health problems, but it could lead to fire hazard issues. And then we also will, Michelle?
Yeah, yes.
Yeah, can you help me with this question as well? Yeah.
Okay, so I think this dust accumulation, it's good to have if we can control the dust that's being produced. Because if we look at the traditional equipment that's available right now, right, some of them comes with this vacuum that comes together with the grinder. It will help to reduce the dust produced when the grinding is occurring. There are also solutions that the handheld grinder doesn't come with the vacuum together with the grinder. So those are typically used, especially if it's not sensitive to dust environment. So I would say that it's good to have, but not essential as an initial solution.
Okay, just to understand, what's the current practice? Is it that workers stop work temporarily?
If the place is too dusty, is it?
Yeah.
There isn't a measure right now, but if it really is too dusty, then yeah, the workers wouldn't go into the space.
Okay. Any other safety considerations that is important to consider?
Safety consideration is because during the grinding process, the disc is spinning, right? That if anything dislodges, it should automatically stop the whole operation. Because the disc itself, it's a cutting object.
Yep.
And while it's spinning, if it really dislodges and fly and hit someone, it will probably be quite a serious accident.
Yep.
Yeah.
I would agree. Yeah. Thank you so much for sharing these additional insights. With that, yeah, thank you so much for presenting and answering the questions. I would like to proceed to the next challenge.
Thank you.
Hi, Mr. BJ.
Hi, Shivan.
Yep. So next we have BJ Joseph from Chuanling Construction, and he will be presenting on the challenge statement, automated installation of noise barrier. Just to set it to full screen, and then we are good to go.
Hi, everyone. Thank you, Chipeng, and thank you, everyone, for giving us the opportunity to present our challenge statement, which is the automated installation of noise barrier panels. So my presentation today, next slide. I'll share the background of this challenge statement and then explain the current practice of installation of the barriers, and then the opportunity areas and key challenges and the expected outcomes. Chuanling currently is involved in two noise barrier projects along the viaducts. And you can actually see these noise barriers along the roads, along the MRT tracks. So these noise barriers typically come with an operation which is pretty repetitive, and that will be explained in the next slide. What you see here is 2 columns and then the barriers installed in between the columns. So the operation that we are trying to automate is the installation of the panels itself. So once the columns, the vertical members and the horizontal members are installed, the noise barrier panels need to be slotted in from the top to bottom, which you can see on the right-hand side. So this operation at the moment involves about 4 workers plus a lifting team. But in terms of operation, it's a very repetitive process. Panels need to be lifted up and then it needs to be slotted into the vertical columns and then slid down all the way to the bottom. And the current panel that we are doing, we have to do about 9 panels and multiply that by about 2 kilometers. We have something like 13,000 panels to be installed over a period of time. So this being a very repetitive process, we thought there is a potential of automating the whole process. Next. So this is a visual representation of how the work is done. And this process keeps repeating itself. So what we consider as an opportunity to automate is a robotic solution that can actually install the noise barrier panels. So in terms of operations, the solution must be able to transport the panels to the point of installation in a manner that does not cause damage to the panel or distort their shape. So it has to be lifted off the ground, then it has to be brought to the point of installation, which is the top of the column, and then it just needs to be slided down. So it must consider how the panels are collected. It must have a place for storage of the panels. It look at the accuracy of the column structure and basically just slide it down all the way. So currently we are taking about 10 to 15 minutes per operation for each structure. So we are also assuming that the robotic solution would typically take around the same time. The solution should ideally be able to automate moving to the next column once one column is complete. And it should also be designed to access a height of at least 5 meters. What we are doing currently is about 5 to 6 meters. And then some of the work sites have heights almost up to 12 meters also. Next. So these are slides which shows how it is done and what is a final finished product. So the robotic solution should collect, install the noise barrier within 10 minutes, reduce the machinery and manpower involved in the whole process. I think that's a very quick presentation of what we expect the solution to do. I'm ready to pick up questions right now.
Thank you, Mr. BJ. So once again, if you have questions, do submit them under the Q&A panel. Okay, so question from my end. So what are the things important to consider regarding the environment, such as the terrain? Like, is the operations done during daytime, nighttime? Do we need to be sensitive with the noise level?
Typically, these operations don't create too much of noise, but it depends on the project itself. So if it's done on a new project, it can be done during the day. But if it's done on existing roads and existing viaducts, lane closures may not be possible during the day. And so then it may involve night works.
So once again, if you have questions regarding this challenge statement, do send them to bm@padang.co. Thank you so much, BJ, for your presentation. We'll be proceeding to the next challenge statement.
Thank you, Jimmy.
So we are at our final challenge statement. So automated floor tile grouting. With that, I invite Bernard Leong from Bohab to present on this challenge statement. Over to you, Bernard.
Yeah. Okay. Can you see the presentation now?
Yes.
Okay. All right. Wait now. Okay. First of all, I thank the presenters for taking up this challenge statement, and also my name is Bernard. I'm from WarHub. Also, this project has also, I'm the lead for this particular challenge statement, but there are also 3 other companies involved. There's Drag Asia's, Gincha, and SoyBuild. So to first start off, just to give a quick introduction on WarHub, we are a main contractor in the built environment, and we also do civil projects. Our most well-known projects that have been known is the Jewel at Changi, Gardens by the Bay, the Interlace, and the upcoming Punggol Digital District that's on there. Now, so to come to the project itself. So just to give a little bit of the background, grouting is actually the process of actually filling the gaps in between tiles. Typically, you have either ceramic, marble, granite, etc. For the final finishes of floor and wall. It's pretty labor intensive and repetitive process that demands time and skill to achieve the desired finish quality. And in the main contractor is under what we call QM works, or quality management works as such. There's actually, in the whole grouting process, there's actually 5 major steps. Okay. First thing is the mixing of the grout material as per manufacturer recommendation. Typically, you have preparation and cleaning of the area itself. You also need to remove the dirt and unwanted substances from the gap between 2 tiles, and then you apply the grout in the gaps between tiles, and then the grout is packed into the grab using a plastic card or rubber pad. So you think of it as just this kind of motion as such, and then after that is the removal of excess grout and cleaning on the surface itself. Typically, just to give some context, it requires 2 man-days of work for one finished unit. So if you think of a block of condominiums straight up or etc., you will know how many units that you actually require to do that. Now, so I want to come to the opportunity areas and the key challenges. So we are actually interested in the robotic solutions that can actually automate the entire grouting process for floor tiles in an integrated manner. For a start, we want to prioritize the automation of the steps in the grouting process that have the most potential to generate productivity gain and improvements to quality. What do I mean by that? What I mean is, for example, usually in the whole grouting process, there's actually edges and also wall groutings as well. We're going to, for the benefits for everyone, we don't want to do that first. We want to get the flat floors of the grouting done. So what we want to do is that it needs to be able to, I want to highlight a few things that would make this project successful. First, it must accurately identify the tile gaps and autonomously navigate a room up to 20 meters cubed to apply the grout for at least 50% of the room. So that's number 1. Number 2, consistently apply the grout for different tile arrangements. So the tile size used could be as small as 150 mm in width. You must consistently apply grout to fill the gaps of 1 to 2.5 mm with different depths. The grout is actually considered to have applied consistently, such that there's no gaps or excess in the application. This could be, and then the solution must be able to achieve what is called a recessed joint profile. For a flush joint profile, the robot should be able to achieve as close to what is practically possible, and also tailor to different types of composition of grout mixtures and adjust the grout application process accordingly. For inventors out there, specifically for WarHub, we are focused a lot on residential non-landed properties, but this can actually be applied also to builders who are in the HDB space, where the grout is actually, the grout mixture is typically very different. Where the challenge really comes from is the ability to handle different types of grout mixtures and still able to achieve the consistency of what I have mentioned before that. And finally, you should be able to apply grout to the corners and the sides of the floor tiles that interface with the wall. I would suggest that just think of the flat space fast that will actually achieve almost 60 to 70% and leave this remaining 30% for extension. So, just to be quite upfront is that this robotic solution we're looking for actually could take innovative approaches to conduct different steps in the grouting process instead of a step-by-step procedure done by human workers. It should also reduce the time taken to complete the grouting process or even reduce material wastage. Okay, because pre-mixed grout typically is discarded if it just hardens. So the following solutions are also desirable as well. Now, the expected outcomes, what we want to really focus on is a robotic solution that can apply the grout for a room or area up to 20 meters cubed for the floor tiles, which reduces the manpower that need to perform this grouting while improving the quality of work. This solution, what we want to do is actually to help us to reduce the duration taken to complete the grouting of one unit by 50% from 2 to 3 man days down to 1 man day. So I'm happy to take on any questions. Thank you for listening.
Thank you, Bernard. As what Bernard has highlighted, besides Wohak coming in as the lead challenge statement owner, you will also have the opportunity to work with BHCC, Jaeger Singapore, Soilbuilt, and Jintia. So, submit your questions for Bernard to answer. So just starting with a question of my own. So I think we discussed a lot regarding the robotic solution in the challenge statement. So perhaps to talk about the digital interface for the solution, what are the features that might be most useful for your workers, engineer, or management?
I think it's the ability to actually do that grouting process of actually applying the grout to the empty lines, okay, and actually achieve a full grout, at least for most of the floor area, okay, without touching the edges yet and the walls. Because I think grouting of those walls at the moment, you require some reconfiguration of the robotic tool. You may want to design something that is extensible. That means maybe a change of components to be allowed to do walls and maybe doing the edges. But I think if you could actually really get the flat floor up to the accuracy that we want for a grout, I think you could really solve a pretty major part of the problem. Another key consideration is making sure that the robots can one of the key things about productivity is that you could actually deploy multiple of such robots inside all the units maybe within a night, and then and it could also be easily used by the workers, because I think the workers, we still need them there to help to supervise the robot. The robot could be automated robot in doing something very similar to a Roomba, but we still need the humans to actually do that. And the other thing is also, you probably will need a little bit of AI computer vision to be able to see the floor and apply the grout, and also able to trace the line as well. And typically in different, whether it's condominium units or HDB units, for example, what you will notice is that there are different types of flooring. Maybe balcony use a different set of tiling, and maybe the floor within, say, the kitchen, the living room, etc. And you should be able to grout either one of them, and the robot should be able to tell what is the distance, what's the minimum, and able to grout by itself. Yeah.
Thank you, Bernard. So a question from Ivan. So would a better training and Q&A process through technology be within the scope?
Sorry, can you repeat the question again?
Yep. Would a better training and Q&A process through technology be within the scope?
What's a Q&A?
Sorry, QA, quality assurance.
Oh, would training and Q&A. So I'm going to be pretty, Wahab has spent the last 10 years that we actually have a productivity measure that actually allow us to reduce this from a 14-man team down to a 6-man team today. So we have operationally made this very, very efficient. The reason why we think that a robotic solution, because our productivity is kind of reaching what's called, I call the marginal utility. By adopting this specific robotic solution, I think we can actually take the quantum even further. And grouting is like a repeatable process. It's a very repeatable process as such. For those who probably also know, if you look at, say, elsewhere in the world, if you look at like Amazon warehouses, people are already using pick and pack using robotic arms as well. It's a very, very repeatable process that can actually be automated into a type of printing process with a robot as such.
Thank you, Bernard. Yeah. With that, I think we come to the end of our Q&A session.
Thank you.
Thank you so much to our challenge statement owners that have spent their time to be part of this Q&A session. So with all our Q&A sessions completed, next up, we look forward to the applications that will be coming in for BEAMP Cycle 4. So once again, just to remind everyone, if you submit before the 14th of October, we will be channeling your proposal to our challenge statement owners for initial review, which then selected innovators will be prioritized for consultation sessions to further refine the proposal before the final submission deadline. Just pausing to check whether there's any other questions. Right. Thank you all for your time. So with this, we will be ending the Q&A session.